Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have 3x minus 9 the whole divided by x minus 1 into x plus 2 into x squared plus 1, right? So what we've been given is dy by dx and we've been asked to find y. So let's write down what our y is. Our y is integral of the given expression. So I'll go to the next line. So that's my y. Now, looks like I have a rational expression where the degree of the numerator is lesser than the degree of the denominator, right? So I will have to resolve this rational expression using partial fractions. So let's express it in partial fractions. So I have two linear terms in the denominator and I have one quadratic term in the denominator. If you're thinking about how to express a particular rational expression in partial fractions, I request you to take a look at my description. I have discussed about five types of rational expressions and how do we express it in partial fractions, right? So, whenever we have a linear term, we use a constant. Whenever we have a quadratic term like x squared plus 1, we use a linear polynomial in the numerator whose degree is 1, right? So for a minute, I keep y aside and I deal with the expression given to me because I'll have to simplify it before I bring it to a format whose antiderivative I know from first principles or some of the recent identities slash rules I've learned in integral calculus. So this is what I have. I have my first linear expression x minus 1. So I write my partial fraction as x by x minus 1. Similarly, b by x plus 2. And then thirdly, I have a quadratic which is x squared plus 1. So I write it as cx plus d, which is a linear polynomial, right? So now the common denominator for this particular expression, what we have is x minus 1 into x plus 2 into x squared plus 1, right? So I'm going to make the denominator common for this particular expression. And when I do that, what do I get? So first, let's write down our denominator. My common denominator is nothing but x minus 1 into x plus 2 into x squared plus 1, right? So when I have this in the denominator, right, my first part, my first expression, which is a divided by x minus 1, what does it become? It becomes a into x plus 2 into x squared plus 1, right? So look at this carefully. So all that I've done is multiply and divide by x plus 2 into x squared plus 1, right? And then I go to the next term, I have a b divided by x plus 2, right? And to express it using the common denominator, what does this part become? So my second expression becomes b into x minus 1 into x squared plus 1, right? So again, you see what I've done is nothing but the term b by x plus 2, I multiply by x minus 1 into x squared plus 1, and then I divide by x minus 1 into x squared plus 1, right? So this is what you get. And in a very similar fashion, I go to the third term, which is cx plus d divided by x squared plus 1. And to express this part of the entire expression using the common denominator, what do I get? This is what I get, right? So I'm going to expand the numerator, keeping the denominator as it is. And what do we get? My first term is 8 times x plus 2 into x squared plus 1. My 8 times x plus 2 into x squared plus 1 becomes 8 times x cubed plus 2x squared plus x plus 2, right? And then I have b times x minus 1 into x squared plus 1, right? So let's expand this and what does it become? It becomes b times x cubed minus x squared plus x minus 1, right? And then finally I come to my c term, cx plus d into x minus 1 into x plus 2. Step 1, I multiply x minus 1 and x plus 2 and I get cx plus d times x squared plus x minus 2, right? So my denominator remains as it is. I know that for the third term cx plus d into x square plus x minus 2, there is scope to do one further level of multiplication. So let's do that as well. So I go to the next step. So this is what I get. I get a cx cube plus cx square minus 2cx plus dx square plus dx minus 2d, right? It looks like I have an opportunity to combine all the x cube terms, the x squared terms, the x terms, and the constant, right? So we're going to do that in the next step, right? I know that we'll have to do this very carefully, and unfortunately, we don't have a much simpler method to do it. And in case you folks can think through of any simpler method to solve these kind of problems in integral calculus, please do mention in the comments, right? So this is what I get post rearrangement. My x cube coefficient is a plus b plus c. My x square coefficient is 2a minus b plus c plus d, right? And then my x coefficient is nothing but a plus b minus 2c plus d. And then my constant is 2a minus b minus 2d, right? So now I try and compare this with the expression given to me, right? The expression given to me is 3x minus 9, the whole divided by x minus 1 into x plus 2 into x squared plus 1, right? Whereas the expression that I have right now in front of me has got x cubed terms, x squared terms as well, right? So now I compare it, my denominator is the same. I compare it with the term in the numerator, which is a 3x minus 9, which means my x cube coefficient is a 0, my x square coefficient is also a 0, right? So what do I mean by my x cube and x square coefficients being 0? My a plus b plus c is a 0. My 2a minus b plus c plus d, which is the coefficient of x squared, is also a 0. And then I come to x, right? I have 3x minus 9, right? And the coefficient of x, what I have in this particular case is a plus b minus 2c plus d, right? Now that becomes equal to, and finally I have in place of a constant, I have 2a minus b minus 2d, right? And the constant that I have in the given expression is minus 9. So what happens to my 2a minus b minus 2d? It is nothing but a minus 9. This is what we have. We've got four unknowns a, b, c, and d. We've got four equations, right? And I'll have to solve for a, b, c, and d, right? Now let's see what do we get post solving for a, b, c, and d. This is what I get, and if you've not understood how to solve this particular problem, please do mention in the comments. I'll be happy to help you out. My a equals minus 1, my b equals 1, c equals 0, and d equals 3, right? Now I go back to the term which I used originally, which is this particular term, right? A divided by x minus 1 plus b divided by x plus 2 plus cx plus d divided by x square minus 1, right? Now that I have my a, b, c, and d, I can rewrite this particular expression using a, b, c, and d, right? And what does it become? This is what I have. My c is a 0, my d is a 3, my a is a minus 1, and my b is equal to 1, right? So the expression that I originally have becomes minus 1 divided by x minus 1 plus 1 divided by x plus 2 plus 3 divided by x squared plus 1, right? Now I go back to my y, which I expressed using the integral symbol. I know that I have simplified y. So my y, which was originally integral of 3x minus 9 times dx divided by x minus 1 into x plus 2 into x squared plus 1, becomes integral of minus 1 divided by x minus 1 plus 1 divided by x plus 2 plus 3 divided by x squared plus 1 times dx, right? So now you see I have expressed y in a much simpler format. Figuring out the antiderivative of this particular expression is not very complex. We have done such problems in the past. So I'm going to use the sum rule and break this down further. My integral of the given expression becomes minus 1 times integral of dx by x minus 1 plus integral of dx by x plus 2 plus 3 times integral of dx by x squared plus 1, right? Now the first two terms are very similar. I have a function of the type 1 by x, right? Where in place of x, I have something of the format ax plus b, right? And in place of ax plus b, I have x minus 1 in the first part and I have x plus 2 in the second part. And we have solved very similar problems, so I'm not going to repeat it. And if you have not understood how I go about solving this, I request you to take a look at my previous videos 249 and see how I've gone about solving integral of dx by x minus 1 and integral of dx by x plus 2, right? I mean, problems of similar type, right? I'm going to write the identities which I'll be using to solve this particular problem. So my first two expressions, what I have in my y, I have minus 1 times integral of dx by x minus 1. So I use the identity what I have pasted, assuming I know integral of f of x dx equals g of x plus c. Then what is my integral of f of ax plus b dx is equal to 1 by a times g of ax plus b plus c. So in this particular case, my f of x is 1 by x, my g of x is ln of mod x, and therefore I have the answer to this particular problem, which is nothing but minus ln of mod of x minus 1. Then for the second one is something very similar to the first expression. So I have plus 1 times ln of mod of x plus 2 plus I have 3 times integral of dx by x squared plus 1, right? I know that my d by dx of tan inverse of x is an identity which I'm expected to remember is equal to 1 by 1 plus x squared, right? So the antiderivative of 1 by x squared plus 1 is nothing but tan inverse of x. And then we have a constant, right? So my third part is also very simple. I use integral of dx by 1 plus x squared equals tan inverse of x. And we have the answer for this particular problem. I know that I still have room for further simplification because my first two expressions, which is nothing but ln of mod of x plus 2 minus ln of mod of x minus 1, right? So I have something of the format ln a minus ln b, which is nothing but ln of a by b, which means I can rewrite my first two expressions as a single expression, which is nothing but ln of mod of x plus 2 divided by x minus 1, right? Plus I have 3 tan inverse of x plus c, right? So there we are. That's the final answer. I don't think I can do any further simplification. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.